Now let's solve our derivation of standard formulas of a parabola at vertex 0 0. Now first, let me have my first parabola. Okay, so let's call this as my x-axis and my y-axis. And if the center of the vertex of parabola is within the origin, so therefore we may say that the axis of the parabola will be within x or y axis. So for the first part, so let this be my parabola. Okay, so let this be the parabola and its vertex is at 0.00. Sorry for that. So our point is at vertex 0 0, and of course we must have our focus wherein let's call this as my A0. This point will be my focus. And from the definition of parabola, that we have a fixed point and a fixed line which are equally distant. So therefore I will have my fixed line, which will I call my directrix. Okay, that okay. So since this is A, so this is understood that since they are fixed distance or equal distance, and the midway of these two parameters are my vertex, so therefore I will call this as my negative A0. Okay, take note that this point is within our axis of the parabola. So take note that the directrix is a line perpendicular to this axis, so therefore we will call this as my directrix. And this goes with the equation x minus x plus a is equal to 0. Okay, so any value of y will have an x equal to negative a, so x is equal to negative a. Okay, now in order to derive our equation for this parabola, let's have our point. So any point within the parabola, let's call this as my P1. Let's try it here. So this will be my P1, wherein it will compose of, since this is at positive x at quadrant 1, so therefore I will assume a positive x and y values. So take note that the distance of xy, which is perpendicular to my directrix, so let's call this distance as my dp. Okay, directrix to point 1, and my focus is from focus to point 1 must be equally distant. So therefore, from here, I will have a value at negative a y, right? Negative a y from this point that is perpendicular to this p1, negative a y. Okay. So from that, since you all know that based on our definition that dp1 is equal to fp1, so therefore by distance formula we can have my dp1 equals the square root of my, let this be my point 1 to my point 2. So we have x minus negative a square plus my y, which is equal to y minus y square. Take note that this will prove that they are perpendicular. So my dp1 will be equal to square root of x plus a square. Next, for my fp1, since my fp1 is equal to the distance from focus to my p, so therefore I will have square root of x minus a square plus y minus 0 square. So my fp1 will be equal to x minus a squared plus y square square root. So from here I will have my dp1, which is equal to square root of x plus a square, which is equal to square root of x minus a square plus y square. Squaring both sides, you will have x plus a square, which is equal to x minus a square plus y square. Okay, in here I will have x square plus, so we will have x square plus 2ax plus a square, which is equal to x square minus 2ax plus a square plus y square. So you will see, or you would notice that in this we'll have a square minus a square is 0, x square minus x square is 0. Then from there I will transpose my negative 2ax, so I'll have 2ax plus 2ax is equal to y square 2ax. So from here I will have my y square is equal to 4ax, in which we'll have the equation of a parabola with a vertex 0, 0 opening to our right.